Exercises. Question 1. An athlete completes one round of a circular track of diameter 200 meter in 40 seconds. What will be the distance covered and the displacement at the end of 2 minutes 20 seconds? Answer. Diameter equals 200 meter. Radius equals 100 meter. Time equals 2 minutes 20 seconds, which is equal to 140 seconds. One round takes 40 seconds. Number of rounds equals 140 divided by 40, which is equal to 3.5 rounds. Distance covered. One round equals circumference, which is equal to 2 pi r, which is 2 pi into 100, which is equal to 628.3 meter. Distance in 3.5 rounds, which is equal to 3.5 into 628.3, which is equal to 2199.05 meter. Displacement. After 3 full rounds, the athlete returns to the starting point. After 0.5 round, he is at the opposite end of the circle, which is equal to displacement equals distance, which is 200 meter. Question 2. Joseph jogs from one end A to the other end B of straight 300 meter road in 2 minutes 30 seconds and then turns around and jogs 100 meter back to point C in another 1 minute. What are Joseph's average speed and velocities in jogging from A to B and from A to C? Answer. A to B, which is 300 meter in 150 seconds. Speed equals 300 divided by 150, which is equal to 2 meter per second. Velocity equals 2 meter per second, same as speed because it's in straight line. A to B. Average speed equals 2 meter per second. Average velocity equals 2 meter per second. A to C. Total distance equals AB plus BC, which is 300 plus 100, which is equal to 400 meter. Total time equals 150 plus 60, which is equal to 210 seconds. Average speed equals 400 divided by 210, which is approximately equal to 1.90 meter per second. Displacement equals AC, which is 300 minus 100, which is equal to 200 meter. Average velocity, which is 200 divided by 210, which is approximately equal to 0.95 meter per second. Question 3. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip, along the same route, there is less traffic and the average speed is 30 km per hour. What is the average speed for Abdul's trip? Answer. Let the one-way distance be d. Time to go equals d by 20. Time to return equals d by 30. Total time equals d by 20 plus d by 30, which is 2d plus 3d by 60, which is equal to 5d by 60, which is d by 12. Total distance equals 2d. Average speed equals total distance by total time, which is 2d by d by 12, which is equal to 2 into 12 by 5, which is equal to 24 km per hour. Question 4. A motor boat starting from rest on a lake accelerates in a straight line at a constant rate of 3 meter per second square for 8 seconds. How far does the boat travel during this time? Answer. U equals 0, A equals 3 meter per second square, T equals 8 seconds. Use formula S equals UT plus half AT square, which is 0 plus half into 3 into 64, which is 96 meter. So, distance equals 96 meter. Question 5. A driver of a car traveling at 52 km per hour applies the brakes. A. Shade the area on the graph that represents the distance traveled by the car during the period. B. Which part of the graph represents uniform motion of the car? Given speed equals 52 km per hour, which is 52 into 1000 divided by 3600, which is 14.44 meter per second. A. In a velocity time graph, the area under the graph gives the distance traveled. We have to shade the area under the deacceleration curve after the brakes are applied. B. The portion of the graph with a straight horizontal line, constant velocity represent uniform motion. Question 6. A figure shows the distance time graph of 3 objects A, B and C. Study the graph and answer the following questions. A. Which of the 3 is traveling the fastest? Answer. The slope of B is greater than that of A and C. Hence, B is moving the fastest. B. Are all 3 ever at the same point on the road? Answer. No, because the 3 lines are not intersecting at any point. C. How far has C traveled when B passes A? Answer. By the time B passes A, C covers a distance of about 9 km or above. D. How far has B traveled by the time it passes C? Answer. By the time B passes C, it has traveled 6 km. Question 7. A ball is gently dropped from a height of 20 meter. If its velocity increases uniformly at the rate of 10 meter per second square, with what velocity will it strike the ground? After what time will it strike the ground? Answer. U equals 0, A equals 10 meter per second square, H equals 20 meter. Using formula, v square equals u square plus 2as, which is 0 plus 2 into 10 into 20, which is equal to 400. V equals square root of 400, which is equal to 20 meter per second. Use s equals ut plus half at square, which is 20 equals 0 plus 1 by 2 into 10 into t square, which is t square equals 4, which is equal to t equals 2 seconds. So, it strikes the ground with 20 meter per second in 2 seconds. Question 8. The speed time graph for a car is shown in figure 7.11. Find how far does the car travel in the first 4 seconds. Shade the area on the graph that represents the distance traveled by the car during the period. Answer. From graph figure 7.11, distance in first 4 seconds equals area under curve from 0 to 4 seconds. This is a trapezium. Speed at 0 second equals 0. Speed at 4 second equals 6 meter per second as per graph. Area equals 1 by 2 into v1 plus v2 into t, which is 1 by 2 into 0 plus 6 into 4, which is equal to 12 meter. B. Which part of the graph represents uniform motion of the car? The limiting flat portion of the curve describes the constant speed of the car, that is a speed of 6 meter per second. At this stage, the acceleration of the car is 0. Therefore, a portion of the graph between t equals 6 seconds to 10 seconds describe the uniform motion of the car. Question 9. State which of the following situations are possible and give an example for each of these. A. An object with a constant acceleration but with zero velocity. Answer. Possible. Let A be thrown in vertically up with some initial speed u. After some time, its velocity decreases and at the maximum height, its velocity will be 0 but it has a constant acceleration 9.8 meter per second square in the downward direction due to gravity. B. An object moving with an acceleration but with uniform speed. Answer. Possible. When a body is moving in a circular path with constant speed, it is accelerating due to change in direction of motion. C. An object moving in a certain direction with an acceleration in the perpendicular direction. Answer. C. Possible. Let a stone is tied and its end with a string and is whirled in horizontal circular motion with the other end of the string. It has centripetal acceleration pointed towards the center. Hence, the acceleration is perpendicular to the motion of stone. Question 10. An artificial satellite is moving in a circular orbit of radius 42,250 km. Calculate its speed if it takes 24 hours to revolve around the Earth. Answer. Given radius r equals 42,250 km, which is 4.225 into 10 to the power of 7 meter. Time equals 24 hours, which is equal to 86,400 seconds. Circumference equals 2 pi r, which is 2 pi into 4.225 into 10 to the power of 7, which is approximately equal to 2.653 into 10 to the power of 8 meter. Speed equals distance divided by time, which is equal to 2.653 into 10 to the power of 8 divided by 86,400 seconds, which is approximately equal to 3071 meter per second. So, speed equals 3.01 km per second. Stay tuned.